Video, we're going to focus on inequalities with absolute values. Now notice here that these two problems they kind of look the same, right? The difference is that we have less than, sorry, greater than, and then we have less than on the other one. Okay, cool. But what does that mean when we have inequalities? So what I mean by this is we have to think about, is it an or and statement? So the way to remember whether the problem is a or and an and, let's think about it like this. So remember the inequality symbol? It's the monster, right? In this case, we're going to call it a wolf. So the way to tell ourselves, hey, is this a or and statement, is the following. Or the wolf eats you, and then it runs away. So in other words, if this is facing the absolute value this way, then this is a or statement. Or if it's facing this way, this is a and statement. So that's something to recall. So once again, to differentiate whether it's going to be a or and statement, consider this. I'm just, or the wolf eats you, and then it runs away. So if it's facing the absolute value, like this one here, then this is going to be a or. But if it's facing this way, then this is going to be a and. And I talk about more what it means to be a or and an and, just in a few minutes. Like again, since the symbol is facing our inequality, or the wolf eats you and then it runs away. In this case, the wolf is facing the inequality, so it's a or. Great. By facing, I mean it's on the left. So just recall for absolute values, for the absolute value function, we have two cases. We have the positive case and we have the negative case. So for the positive case, you're just going to copy as is, but remove the absolute value symbol. In other words, just remove the absolute value symbol and copy it as is. This is the positive version. Now for the negative version, we're going to also remove the absolute value symbol. So it's going to be x minus 3. But for the negative case, we're going to what? Flip the symbol, the direction of the symbol. So it's going to be facing this way, and we're going to multiply the thing on the right, whatever that is. In this case, 3 by negative, so it's -3. So here I wrote the rules for just for how to deal with both the positive and the negative case on the right hand side of the screen. And notice that at the beginning, the inequality symbol, it's facing the absolute value. So remember our little song, or the wolf eats you, and then it runs away. Since the wolf eats us, the wolf is facing us, it's the or statement. Okay, and remember mathematics, or in particular in this case, this means union. Okay, so let's solve each of these individually. I'm going to add +3 to both sides, so I get x is greater than 6, or and on the right, on the one on the right, -3 minus 3, I'm going to add 3 on both sides, so I get x is less than 0. And then finally, we have this. But wait, what does it mean to be an or statement, right? So recall from the previous video of how we actually drew the number line for these, or just a number line representing the inequalities. So let's do this. So, but here the trick is, I'm going to have two inequalities, and I'm going to list the numbers in order. So I'm going to list 0 and 6. And for the x is less than 0, recall I want all the x's less than 0 but not 0. So that means you know, looking at 0 here, numbers to the left are smaller than 0 because I want x is less than 0. So I'm going to go this way. Now for the other case, and notice that I use parentheses because I do not include it. Now for the x is greater than 6 one here, I go to the 6, and looking at the statement here, it says that I want x is bigger than 6. So remember, numbers bigger than 6 are to the right of it. So that means I'm going this direction. So now I put, and because it's a or, you could think of as or just taking both of them, like both of these rays, and just putting them together. So in other words, sorry, and an easier way to think of it is just copy and paste for or. So in other words, it's going to be 0, and I'm going to have one for 6 this way. So this one here should be our final picture. Now, depending on your instructor, this could be okay, but maybe they want you to write it in interval notation. Okay, so let's do that. Let's So here I have another problem. Sorry about that. I know it's still running. So here we have another problem, and we have to decide whether just whether the problem is a union or if it's an intersection. And recall, in other words, if it's a or is it an and. And recall that if the wolf is facing you, in this case facing inequality, or the wolf eats you and then it runs away, since it's facing us, it's a or statement. Okay, cool. So it's a or. That's the first thing that you have to decide, whether it's a or and an and for these types of problems. It's very important. Okay, so now recall that we have both a positive and the negative case. So for the positive case, I'm going to copy as is, but I'm going to remove the absolute value symbol. And for the negative case, I'm going to remove the absolute value, but I have to change the direction of the inequality, and I have to multiply the side opposite the absolute value by a negative. So the 5 becomes -5. So solving these individually, for the first one here, I'm going to subtract -2 on both sides. So I get x is greater than 3, or, and then for this one, I'm going to subtract by 2 both sides. So I get x is less than -7. So writing this now, okay, so now I have both of these here. So now what I do now, it's that I have to create my number line, 2 number lines, and then I'm going to write the numbers. So you have to put them in order. So -7 comes before 3. So like this. And then looking at this case, I want x's that are smaller than -7. So at -7, I locate it here. I want to go to the left. And then for this case here, for x greater than 3, I want x's that are bigger than 3. So that means that I need to go to the right of 3. So I locate 3 here. So I go this way. And again, notice my choice of symbols. I use parentheses instead of brackets because of the symbols. All right, great. So because it's an or statement, now what we do is that we we copy and paste the number lines exactly how we see them. So I'm going to copy and paste the red number lines, and to be more mathematically precise, these are rays. For those of you who have taken geometry, these are rays, but I'm gonna call them number lines. It's slip of a tongue. So now we have those, and remember it's an or statement. So remember, or, it's the same as union. So the way how I do this is, remember, we go from left to right. So I'm walking, let's say, I don't know, I'm like at Mars or something, and I'm walking to Earth. So the distance from Mars is very far. So that's why it's going to be what? Negative infinity. So I keep walking, I'm walking. Oh, but remember, this is like a wall. So I came past the wall, but notice that it's a parentheses. In other words, it doesn't include -7. So that's is why I write parentheses. But then I also need to what? Jump over. So I have to long jump all the way. And the jump is represented by the union. So the way to think about it, to remember this, is that, hey, the union means what? We're jumping all the way over. So that's what it signifies. You could think of this as the geometric interpretation. Think of a long jump. So I land close to 3, but not 3, because remember, I cannot touch 3. So it's going to be 3 to infinity, because I'm walking over and over again. So this should be your final answer in interval notation. But what if I take the original problem and I just change it a bit? So here, I use like a less than or equal to symbol. Okay, that's fine. Remember, the first step is that I have to determine, for these type of problems, is it an and or an or statement, right? And remember, this is us, or the wolf eats you and then it runs away. So since the wolf is not facing us, it's running away, right? So it's an and. One more time. Or the wolf eats us. In other words, if the wolf is facing us, it's going to eat us. So again, or the wolf eats us and then it runs away. So if it's running away from us, it's an and statement. So for this problem, again, because the wolf, it's not facing that, the absolute value, it's going to be a and. Okay, and just like the or case, we proceed as as normal. In other words, we have two cases. We have the positive case and we have the negative case. So for here, the same. We just copy exactly how it is, but remove the absolute value. And again, we're going to copy the inside of the absolute value, but we're going to remove the absolute value symbols, the bars. But because for the negative case, remember, we always have to flip the sign, and whatever's on the opposite side of the absolute value, we have to multiply by a negative. So now, remember, it's an and, so I would like to write the and statement. So now I'm going to -2 on both sides, and then here I'm going to -2 on both sides. So I get x is less than or equal to 5, and x is greater than or equal to -7. And again, just like the previous case for the or, we have to draw two number lines, but there's going to be a bit of a difference. So remember to write them in order, i.e. the -7, it's a smaller number than 5, so I'm going to write that one at the top, and the 5, I'm going to write it at the bottom. So looking at this case here, I want x's that are greater than or equal to -7. And remember, x's that are bigger are always to the right of a number. So locating -7, that means I have to go this way. And because it has this symbol here, that means that I make it a bracket. So whenever you have the little equals or the little tick mark at the bottom, um, it's a bracket. And more of that on the previous video. And for the 5, we want x's that are smaller than 5, smaller than or equal to 5. So locating the 5 at the bottom, I'm going in this direction. Now the difference between the and of the or is that, remember, for the or, it's we copy and paste them together. For the or, we copy and paste together. For the and, it's a bit different. what I mean by a bit different is that for the end statement, it is the region of overlap. In other words, where they both exist at the same time. So what that is saying, it's, hey, I'm going to stretch this out a bit more to make it more obvious. What that's saying, hey, it starts here. So this would be our region. Notice that they both exist. They both go in this direction here. But it stops what? Here. In other words, where they both exist at. Or in other words, by exist, they overlap. So it goes from what? -7 to 5. And remember to keep the original symbols, which are brackets. So in this case, it's going to be -7 to what? 5. And this would be your solution. Again, for or is we copy and paste, just number lines together. And for the n, it's only the region of overlap. All right, cool. Now, let's do a few more problems. Okay, so here I actually give you like the graph of the inequalities. So now I want you to write the solution set interval notation, right? Okay, well, let's do it two ways. Let's see what happens when we have an or when we take the and. In other words, the union. And let's do it as well for the case for when we take the intersection. Okay, for the union, aka the or, it just means copy and paste. In other words, you take the two number lines together and you copy and paste them into one. So for this one, I'm going to take this here. I'm just going to copy it exactly as is. And I'm going to take this and what? Copy it exactly as is. So now it would be what? This whole picture if we were to do it graphically, right? But let's write an interval notation. Remember that we always read it from left to right. And since this is array, we're going, hey, all the way over here. So that means we're from negative infinity. We're walking, and then we hit this -3, but we cannot touch it. We get very close to it. And then we what? Jump over. We're jumping over all the way to the 5. And remember, because we're doing the union first, the jump is represented by the U. And because we have the bracket, that means that we could actually be 5. We could touch the 5. So it's 5. And remember, we're walking. Remember, left to right. So this would be the case for the or. Now for the case of finding like just the end, right? In other words, end is what? Intersection of these two inequalities. Remember, for the end, because we don't copy and paste them together, it's the region of overlap. So here, it's here. Okay, it doesn't go past the -3, and here it starts at the 5 and it goes here. But notice that but notice that they don't overlap, right? So in other words, so there's no place of overlap. So therefore, for the end case, the solution, it's going to be empty. In other words, because they don't overlap, it's empty. Like a more, I would say, rigorous way or smart ass way to write this is just writing mathematics. This little is like a 0 with a slash mark. This is called the empty set. So in other words, the intersection of these two inequalities is empty. There's nothing there. They don't have nothing in common. Therefore, it's empty. But maybe that last problem was a bit weird, right? Here's one that's a bit easier. So here, what I care about, it's the end. In other words, the intersection of these two rays. Okay, so let's talk about it. Remember, it's the region of overlap. So what I like to do is I like to do this, do this, do this, do this, do this, and then just shade it in, shading in. And notice where both of the colors overlap, the region of overlap, and that's going to be the end. So in this case, it exists. They overlap from 1 to infinity because it keeps going, right? So in other words, intersection, it's 1 to infinity. Now, what if I take the same two inequalities, but this time I care about the or, in other words, the union. And you remember what that means. It just means to what? Take them as is and just copy and paste them. So I'm going to draw the first one. Remember, it's copy and paste. And then I'm going to take the second one and I'm going to what? Copy and paste it, right? So it's going to be from 1 to what? Infinity, right? And remember, because we're copying and pasting them, really in this problem, it just becomes exactly what? 1, because we're joining them together. So it actually becomes 1 ray, and it starts at -3, 2, and it keeps going on and on and on and on. We're walking forever to infinity. So for these types of problems, when is it that we have, like no solution? Oh, and that's kind of interesting, right? When is it that we have no solution? And this is as follows. So recall that the absolute value function, it's defined for x if x is greater than or equal to 0, or negative x if x is less than 0. This is why, and this is a very formal way to write it, so it may look a little bit too confusing, or for those of you probably, nah, he's making it too difficult. I'm actually going to stop watching the video. No, just give me a minute of your time and I would break this down for you. So here, notice that, let's pick a number. Let's say I pick a 3. So in other words, let x equals 3. So I'm going to plug it in. So then we have to decide, hey, 3, it's a number, it's 0 or bigger, right? It is. So in other words, which version do we choose? Do we choose this one or this one? We're going to choose the first one because it's what? 0 and bigger, right? So in other words, absolute value of 3 is 3. Now, what if I pick -3? Okay, for x is -3, we know that -3 is less than 0. So this is why I need to use this version. So in other words, I'm going to multiply -3 by a negative in front. So I get what? 3. So this is why in elementary school, middle school, high school, or even in college, your teacher tells you, hey, anything that you put inside of the absolute value, it's either going to be 0 if you plug in 0, or it's going to be positive, regardless if what you plug in it's negative or positive. It always comes out what? 0 or positive. This is the reason why. Okay, so barring that, the absolute value is never negative. It's never negative. So when we have no solution, it's going to be, we can have something weird like this. It doesn't have to be too complicated, but let's say, is absolute value ever, sorry, it should be the other way. Is it ever smaller than a negative number? No. So in this case, it's going to be what? No solution. But even it doesn't, even the insight of it, of the argument, doesn't have to be so complicated. We could take something simple like this. Let's say 5, -5. Is -5 greater than the absolute value of x? No. Remember, the absolute value, it's never negative. So therefore, we have what? No solution. In other words, to simplify what we just talked about, is there's no solution for absolute value inequality problems if the absolute value is smaller than a negative, or when the negative is greater than the absolute value. Like in other words, if the wolf, it's eating the negative number and not the absolute value. Right off the bat, there's no solution and we stop. So sometimes I'm a jerk. What I mean by jerk on tests is I'll put something complicated like this. And this is for me to see whether you know the material or not. Where do you understand the concept well? So in this case, the first thing you do is you analyze the problem, right? So notice that this whole absolute value junk thingy is less than -300. And from the previous conversation we had, This has what? No solution. So right off the bat on a test, you can literally get easy points for solving this problem. 3 seconds, no solution, and boom, we're done. Now, if you want me to solve more complicated problems of absolute value inequalities involving like involving more than one inequality with variables inside, or even where we have to when the power of the x is not one, meaning a quadratic or quadratic cube, etc., then yeah, just drop a comment down in the comments and say, hey, I want to see these, and I will gladly pick some problems out and work them out with you. Like, just as always, please like, share, and subscribe. Every subscription helps. And thank you if you found these videos useful. Have a great one.